This video is designed to go with 15.2 from the Musser book, and we're talking about the equations of circles. And so the nice thing about this is that if we take a look at a circle, and I'm just going to put the XY coordinates in, the XY axes in, because it's going to be a little easier to see this when you have a vertical and a horizontal line within the circle. I just want to show you what's going on. So you should all realize that if this point is at the center, then any line connecting that point to the edge of the circle will be the radius. And I can do that anywhere, okay? So that would be the radius, this would be the radius, this would be the radius. And I can put that line anywhere, going from the center to the outer of the circle, because that's the definition of radius, okay? It's half the distance across the circle from the center. So now watch what we can do here. I can make these tiny triangles inside the circle. And if I do that, because they would be on an axis, a grid, all of these are going to be right triangles. And so because of the Pythagorean theorem, what I know is that whatever this changes, okay, so this is going to be some x minus x1, okay, or x2 minus x1, whatever. And this is going to be some y minus y1, because again, it's the difference in y values. And I know that y minus y1 squared plus x minus x1 squared is going to have to give me my radius squared. And so what I've basically shown here is that that is the formula for a circle, because the radius is going to be consistent the whole time. I can take any ordered pair that it goes to on the circle, and this will always be the formula for the circle. Now, the way the book does it is it calls them A and B instead of X1 and Y1. I just did that to remind you of all the previous videos. But we could say that it's X minus A squared plus Y minus B squared equals R squared. And you can see that it has that same feel from the Pythagorean theorem. It turns out that AB is not just some random point, okay? It's going to be the center of the circle. Now, why is that true? Well, if you think about this point being 0, 0 here means that whatever this length is simply going to be x, and whatever this is here, again, it's going from 0, this is simply going to be y. And so what I'm saying here is that this x1 and this y1, this ordered pair, in this example, this ordered pair was really 0. And so what I really did was I had the center marked at 0, but I can shift this circle anywhere. It doesn't have to be centered at 0, 0. Maybe my circle was over here, but I should be able to do the same thing, and I should be able to figure out this triangle. The problem is that because this isn't 0, 0, this has some value, x1, y1. This has some value, okay? And this has some value. And so I'm going to have to do, again, the same exact thing that I did with the distance formula back in the previous videos. So this is going to be a change in x. This is going to be a change in y. And the radius is going to be our hypotenuse. And so if I shift this circle anywhere on my axis, I will always get this formula for the formula of a circle. And it comes directly from, again, the Pythagorean theorem. So who knew that was that useful?